Welcome to the course on machine learning using Python programming. So, in this lecture, we will see different types of data that are used in the machine learning. So, data is a collection of records, or we can say it is a related information. So, let us see different examples of data. If we talk about a data set on students, then we can say that it will be a collection of records of students, and we may have student ID, student name, student address, student current semester. So, these may be different features of the student data set. In the same way, if we talk about a student performance data set, in that case we will have records of performances of different students. So, here the features will be student name, student marks, student subject and so on. So, in the data set we can say that each and every row is corresponding to the instance or record. In this particular case, so each row is corresponding to a student or a student performance, while a column is corresponding to a particular feature, that is also called as attribute, and it gives us a specific characteristics of the object of which we are having that record. So, in this way we can say your data set on which machine learning works, it contains number of records or instances, and each and every record is represented as a number of features. This is the example of a student data set and a student performance data set. So, here in both of these two data sets we have 4 features. In a student data set, the first feature is roll number, another feature is name, then gender and age. In a student performance data set, we have roll number, math, science, percentage. These are the 4 features. In the first student data set, we have 6 instances, or we are talking about 6 students. In the same way, we can see here in second data set also we have 6 instances. So, 6 rows are there, so 6 instances are there. Now, data can be broadly divided in 2 types. One is qualitative data, another is quantitative data. So, qualitative data is also called as categorical data, and quantitative data is also called as numerical data. Then this qualitative or categorical data can also be divided in 3 categories. First is called as nominal, then binary and ordinal, or we can say that categorical data can be nominal data or binary data or ordinal data. And in the similar way, quantitative or numerical data can again be divided into categories, interval as well as ratio data. So, let us see these different types of data types in detail. First, we will see qualitative data. So, qualitative data, as we have seen, it is also called as categorical data, and it is divided in 3 subcategories: nominal, binary and ordinal. So, let us see first what is nominal data. So, nominal data is the data in which we do not have numerical values, as it is the example of categorical data. Definitely it should not have numerical values, it should have only named values. So, each nominal data and corresponding variable will have only named values. So, these nominal values cannot be quantified, these are named values. So, example of these nominal data are blood group or nationality or gender. So, these are different examples of nominal data. So, in blood group, if we see what are the possible values in blood group. So, A, B, O, AB, B positive and so on. So, these are different names that are the possible values in blood group. In the same way, if we talk about nationality, So, Indian, American, so these are different names that are possible values in nationality attribute or feature. In the same way, for gender we can say male, female. So, these are different possible values, and all these values are named values, these are not numerical values. So, this type of variables are called as nominal variables, or this type of data is called as nominal data. So, it is one of the type of categorical data. So, a special case of nominal data is when that data contains only two labels, and for example, if it is pass or fail. So, for a student, if we are having the status pass and fail, so it is having only two data. So, this we can say that as a binary data. Then which operations we can apply on nominal data? Why we are talking about different operations? Because we want to analyze the data set. When we are preparing our data set for machine learning models, for training machine learning models on this data set, first of all we need to prepare or clean our data set or understand our data set. So, to understand our data set, generally we perform some operations on the data set. So, let us see which operations we can apply on nominal data. So, addition, subtraction or multiplication, division, we can't perform these operations on nominal data, because nominal data are having only named data. So, we can't add two names. So, we can't add B positive and AB blood groups. So, since we can't perform addition, subtraction, multiplication, we can't take mean or variance, these statistical features we can't calculate for nominal data. The only possible operation is basic count operation. We can count most frequently occurring value. So, if suppose for the patient's blood group is given, so we can count, okay, B positive is the most frequently occurring value. So, this is the only operation that we can perform on the nominal data. Then binary data. So, binary data is again the example of categorical data. So, in this case your attribute will have only two values, and that you can always correspond to 0 or 1. Then example is, suppose there is a feature smoker. So, in some persons the value will be 0. So, it is corresponding to non-smoker, and if the value is 1, it means the person is smoker. So, these type of attributes are called as binary attributes or binary data, and it also comes under the categorical data. So, now binary attribute can be either symmetric or non-symmetric. Symmetric if 1 and 0, these two possible values are symmetric values. It means your the data set that contains this binary attribute. So, there are 50% chances that the values may be 0 and 50% chances values are 1. So, weightage of 1 and 0 is same in this case. Like if we are having a feature, suppose gender. So, in that case male or female, these are the two possible genders, and there is no we are not giving any weightage to male or female. In that case, this gender we can treat as a symmetric binary data. So, definitely it will depend on the problem. If you are giving more weightage to male, in that case it will be, you will treat this gender as a asymmetric attribute, otherwise it is a symmetric attribute. Asymmetric attribute, generally those attributes are there where we have two values and one of these values is having some more weightage. Like if tumor are there, so if it is a benign or malignant, so generally we are focusing on those tumors that are malignant. So, here this type of data is called as asymmetric data. Then the third type of categorical data is ordinal data. So, ordinal data is a data that is satisfying all the properties of nominal data that we have seen, but here the values of that ordinal data can be ordered. There will be a natural order in these values of the ordinal variable. So, like customer satisfaction. So, in customer satisfaction, if we are having values like very happy, happy, unhappy and so on. So, there is a natural order among these. We can write them in one order like very happy, then unhappy and so on. In the same way, grades. So, S grade, A grade, B grade, C grade. So, there is a natural ordering among these values. So, if you are having this type of variable where although they are named values, so that is why this is a categorical variable, but there is and it is nominal variable, but there is one more feature or characteristic of the data, that ordering of values are possible, then it is called as ordinal data. So, now what operations we can perform on ordinal data? So, like nominal data, basic counting is possible. So, we can find the mode of the feature, mode of the data can be identified, and since ordering is also possible in this case, in the case of ordinal data. So, median as well as quartile we can also calculate for ordinal data, but since we can't add these values, that is why mean cannot be calculated for the ordinal data. Then quantitative data, this is the second type of data. So, categorical data was the first type of data, under which we have seen three types of data: nominal, binary and ordinal. Now, in quantitative data, so quantitative data refers to the data in which we have information about the quantity of some particular object. So, it means it can be measured. So, example is marks. So, we can talk about marks of the students. So, marks are measured quantity. So, if we are talking about marks as a feature, so this is a quantitative feature, this is a quantitative data or numerical data. So, there are two types of quantitative data, one is interval data, another is ratio data. So, let us see what is difference between interval data and ratio data. So, interval data or interval scaled data. So, interval data is of course numeric data, because it is coming under the continuous data or numerical data. So, in this data not only order is known, so that was a property of ordinal data. So, that property also holds for interval scale data, but exact difference between values is also known. Like if we talk about temperature, Celsius temperature. So, difference between 12 degrees Celsius and 18 degrees Celsius is 6. So, same difference between 15.5 degrees Celsius and 21.5 degrees Celsius is also 6. So, difference between two values is very much defined. So, other examples of interval scale data are date, time and so on. So, now we can see which operations we can perform on interval scaled data. So, we can perform addition, we can always add two values of temperatures, we can subtract them also. So, we can say that for interval data we can calculate central tendency. So, that is mean, median, mode, and standard deviation we can also calculate for the interval scale data. Now, for interval scale data there is not any true zero value for that data. Like if we talk about temperature, that is one of the example of interval scale data. So, there is no zero data. Zero data means I am not talking about 0 degrees Celsius. 0 degrees Celsius it is representing some data, minus 1 degree Celsius is also representing some temperature. But if we talk about no temperature, it is not not fitting in this particular example. 0 temperature is not any meaning of this. So, that is why there is no true 0 value in interval scale data, and because of that we can say that ratio cannot be performed. We cannot take ratio of two values of interval scaled data. We can take addition, but we can't take ratio, or multiplication does not seems fit on this data. So, for example, if we talk about 40 degrees Celsius, so 40 degrees Celsius is, we can say it is equal to 20 degrees Celsius plus 20 degrees Celsius. But if we say that 40 degrees Celsius means it is twice as hot as 20 degrees Celsius, then it is not correct. So, this was interval scale data. Now, the second type of continuous variable is, or continuous data is, ratio scaled data. So, ratio scaled data, in that data absolute 0 value is available in the ratio scale data. So, we can say that it is following all the properties of the previous data, and one more property, that it is having absolute 0 value, and that is why all operations we can, all means addition, subtraction, multiplication as well as division. So, all these 4 operations we can perform on absolute ratio scale data, and so we can calculate central tendency, mean, median, mode, method of dispersion, standard deviation. So, all these operations or statistical features we can calculate for the given ratio scaled data. Example of ratio scaled data are height, weight, age, salary and so on. There is another way of categorizing data, that is discrete versus continuous data. So, discrete we know. So, discrete values, binary is one of the example of discrete attribute. So, discrete attribute is that attribute that is having values that can be mapped to some countably infinite set of values or finite set of values, or we can say that to any integer values. So, these are discrete values. Continuous values. So, continuous values, in that case we can map it to the real numbers. So, we can't map it to the integers, this is the real numbers. So, we can say that it can be represented as a floating point variables, and so discrete attributes can assume finite or countably infinite numbers. Examples are roll number or street number, pin code and so on. And a special case of discrete attribute is binary attribute, so in which it is having only 2 values. And continuous attributes can have any possible values which is a real number. So, examples are weight, price, height, length and so on. This is the one of the example of a data set, that is AutoMPG data set, that is available in UCI repository. So, I request all of you to go through this AutoMPG data set of UCI repository, and in that AutoMPG data set we have different attributes: MPG, cylinder, displacement, horsepower, weight, acceleration, model year and origin. So, all these attributes are numerical attributes. You can check and find values of these attributes, and there is one more attribute, that is car name in this AutoMPG data set. So, car name is the categorical attribute, because names of cars are written in that. So, here MPG is the target attribute. Target attribute means the response variable for which we want to predict values. So, in the given data set, for different instances these MPG values are also given, but your machine learning model can learn from this data set, and then for a new given instance it can predict the MPG value of that instance. So, these are the few instances of that data set. So, different MPG values are given, cylinders given, displacement values is given, horsepower is given, and in the last car name is also given. So, you can see this is a very big data set. Here few instances are shown in this slide, but you can check on the UCI repository this auto MPG data set, you will get the whole data. So, it is having these number of features. All the features are generally numeric or continuous features, only one feature is the categorical feature. Now, there are chances that few attributes you can take as a categorical or as well as a numerical. It will depend on your choice, or it will depend on the problem that you are solving, whether to take it as a categorical or numerical. For example, in this if you see cylinder, so there are only 3 values that are present here, 8, 4 and 6. So, in this case we can treat this feature as a categorical feature. So, we can take 8, 4 and 6 as a names rather than numbers. So, it depends how you are representing or understanding your data set. So, depending on the problem you will need to treat features as a categorical or continuous and so on. So, I am stopping here. In the next lecture we will see some other topics of machine learning. Thank you.